Hey everyone, I hope you're doing well. It's Mr. Irwin. Before we start today's lesson, I want to apologize. I am having some technical difficulties with the computer. I cannot get the webcam to embed on the screen, so we are going to have to go through this entire lesson without you being able to actually see my face, which is probably a positive thing for most of you. You see today's lesson on the screen. We're going to start talking about ratios. So if you want to grab a notebook, a couple sheets of blank paper, they'd be very useful for you as we work through this lesson together. Let's just start with the definition of a ratio. A ratio is a quantitative relationship or comparison of two quantities. Essentially, it is a mathematical object that allows us to compare two numbers, two values, two amounts, two quantities to each other. And to write a ratio, there's actually three different ways that you can write a ratio. And we're going to go over those three ways by looking at this example. At a pet shop, there are 5 cats and 8 dogs. Write a ratio comparing cats to dogs. Now, the most important part of writing a ratio, other than the values or numbers in that ratio, is getting the order of the numbers in that ratio correct. So if you look at this example, we are comparing cats to dogs, which means when we write our ratio, we need to list the number of cats first and the number of dogs second. You can't flip the order or you're going to have an incorrect ratio. So we want cats to dogs. So at our pet shop, there are 5 cats and 8 dogs. So my ratio of cats to dogs will be 5 to 8. And we're going to write 3 different ways, or show 3 different ways we can write that ratio. The first way to write 5 to 8 is just the word 2. We can write 5 to 8. 5 cats to 8 dogs. The second option for writing a ratio is to use a colon to separate the two quantities. So 5, and then it's this double dot with an 8. You'd still read it the same way. It's a ratio, 5 to 8. And then the final way is to write it in fraction form. The number that comes first in your ratio will go on top of your fraction bar. The number that comes second in your ratio, in this case the dogs, will go on the bottom of your ratio bar. Even though this looks like a fraction, you would still read it like a ratio, 5 to 8. All 3 methods are correct. Choose what works best for you. I highly recommend the fraction option because by next week, we're going to start performing calculations with the ratios. And if they're in fraction form, they are much easier to work with mathematically. All right, let's try a couple examples. On your screen, you should see an assortment of shapes. And we have 3 different ratios that we need to write comparing these shapes. The first ratio is squares to triangles. So I need to go through this pile of shapes and count how many squares there are. Well, I got 1, 2, 3, 4 squares, 2 triangles. And we'll count the triangles. There are 1, 2, 3, 4, 5, 6. So we have the ratio of 4 to 6. Don't forget, you could write that in multiple ways. You could also write that as 4 with a colon to 6, or in fraction form, 4 to 6. Any of those are correct. Also, you can reduce these ratios just like you would with a fraction. So if I have 4 to 6, I know both 4 and 6 are divisible by 2. So another way to write this ratio, I could divide both these by 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. So 2 to 3 is the same ratio as 4 to 6. The ratio of squares to triangles, 4 to 6, or we could even simplify it, 2 to 3. Any of those are correct. Next option, ratios of circles to squares. So let's go through the pile here. Let's count how many circles there are. I see 1, 2, 3, 4, 5 circles, 2, and now squares. For squares, 1, 2, 3, 4. So the ratio of circles to squares is 5 to 4. You could write that with a colon, 5 to 4, or in fraction form, 5 to 4. Now, in fraction form, I know this looks like an improper fraction, but because it is a ratio, we do not convert this to a mixed number. We will always leave it as 5 to 4. All right, final example on this page, we are looking at the ratio of triangles to total shapes. So if I come up here to triangles, there are 1, 2, 3, 4, 5, 6 triangles. 2. Now I need total shapes. I need to count how many total objects are in this image. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 shapes. So the ratio of triangles to shapes is 6 to 15. That could be written as 6 to 15 like that with a colon, or in fraction form 6 to 15. And also don't forget, if you wanted to simplify that ratio, that's also permitted. Both 6 and 15 are divisible by 3. 6 divided by 3 is 2, and 5 divided by 3, or excuse me, 15 divided by 3 is 5. So that ratio would simplify 2 to 5. 2 triangles for every, or out of every 5 total shapes. All right, let's do another example. Same idea here. In this example, we are looking at an assortment of letters, and our first ratio is asking us to compare A's to B's. So, counting through my pile here, I have 1, 2, 3, 4 A's to, now we're counting B's, 1, 2, 3, 4, 5, 6. A's to B's is 4 to 6, and whichever method you choose to write 4 to 6, any of those are correct. And you could also reduce 4 to 6 down to 2 to 3 if you wanted to. Next is C's to B's. Looking in this pile, count with me. There are 1, 2, 3 C's. To B's we counted last time, but just a quick refresher, there's 1, 2, 3, 4, 5, 6. So C's to B's is 3 to 6, or you could write it as 3 to 6 with a colon, or 3 to 6 as a fraction. Finally, B's to total letters. We know there are 6 B's. 1, 2, 3, 4, 5, 6. 2, counting how many total letters are on our page. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 6 to 13, 6 to 13, or 6 to 13. All right, our next example, kind of a word problem. It says, during an experiment, Kevin flipped a coin 42 times. The coin landed on tails 22 times. What is the ratio of heads to tails in this experiment? So we're looking for heads to tails. Well, if I come back and I look in this scenario, I want to find how many times did the coin land on heads. Well, I know he flipped it a total of 42 times, and 22 of those times was tails. Well, to figure out how many times the coin landed on heads, I would need to take the total 42 coin flips and subtract the 22 times it landed on tails to figure out how many times it landed on heads. And when we perform that calculation, we find that it landed on heads 20 times. So my ratio of heads to tails, I had 20 heads to 22 tails. And then, just a bonus here, writing this ratio in simplest form, find it the greatest common factor between 20 and 22. What are both of those values divisible by? The largest value that will evenly divide into both is 2. 20 divided by 2 is 10. And 22 divided by 2 is 11. So in simplest form, that ratio would be 10 to 11. 10 heads to 11 tails. All right. Boys and girls, this last slide is all yours. Up here in the corner, you'll see 10 cards with different numbers on them. I want you to use those digits in those cards to find ratios of these 4 examples. Odd to even, sevens to total cards, cards less than 4 to total cards, and then prime numbers to composite numbers. Pause the video, find those 4 ratios. Once you found out 4, hit play again, and come back and check your work to see how you did. All right, hopefully you gave yourself enough time to find the ratio of all of these. Let's check your work. Here we go. First, odd to even. Looking at odds. 7 is odd. 1 is odd. 3 is odd. So I got 1, 2, 3, 4. 9 is odd. 5. 7 is odd. 6. 2 even numbers, which are 2 and 6 and 4 and 4. So 1, 2, 3, 4 even numbers. Odd to even is 6 to 4. Sevens to total cards. I see 2 sevens up here. And then total cards, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 to 10 for the second one. Next, we're looking for cards that have a value less than 4. 2 is less than 4, as is 1 and 3, and 1 again. So I have 1, 2, 3, 4 cards that are less than 4. 2 total cards, we already counted in the last one as 10, so 4 to 10 for that. Finally, prime and composite. 2 is a prime number. I'll put P for prime. 7 is also prime. 1, that's a tricky one. It is neither prime nor composite. 3 is prime. 6 is composite because we can do 2 times 3 or 1 times 6 to get 6. 1 is neither. 9 is a composite number because it has multiple factors, 1 times 9 or 3 times 3. 4 is composite because we can do 1 times 4 or 2 times 2. 4 again, and then 7 is a prime number because its only factors are 1 and 7. So prime numbers, I got 1, 2, 3, 4 prime numbers. 2 composite numbers, 1, 2, 3, 4 of those. Boys and girls, that concludes our lesson on ratios. Please complete your independent practice assignment. Take a picture of your work and upload that file for submission. I'll see you guys next time. Take care.